Welcome to Brain Vision.
This would be the free body diagram for the yo-yo, and essentially a diagram of the yo-yo itself, just to help you in calculating the moment of inertia. So we can say that the velocity of the center of the mass of the yo-yo would be equaling the radius of the yo-yo times the angular velocity of the yo-yo. We're going to say that calculating the moment of inertia, this would be equaling the moment of inertia of a disk, 1/2 mr squared, plus 2 times 1/2 mr squared. And so we can say that the moment of inertia would be equal to 1/2 times mr squared, lowercase m being the mass of the inner hub, so this would be m, and then this would be mm. This lowercase r would be the radius of the inner hub, and then capital R would essentially be the radius of the two outer disks. And so we can say that this would be the moment of inertia through the center of mass would be 1/2 mr squared plus mr squared. And so we can calculate this. Moment of inertia through the center of mass would be 1/2 times 5.0 times 10 to the -3rd kilograms multiplied by 5.0 times 10 to the -3rd meters quantity squared, plus 5.0 times 10 to the -2nd kilograms multiplied by 3.75 meters times 10 to the -2nd meters quantity squared. And we find that the moment of inertia through the center of mass is equaling 7.038 times 10 to the -5th kilograms meters squared. Now, we know that the total mass m is equaling the mass of the inner hub plus 2 times the mass of the outer disks. And so this is equaling 0.105 kilograms. And so we can then apply the conservation of conservation of mechanical energy. For part A, the potential energy initial will be equal to the kinetic energy final. And we can say the total mass times g times h would be equaling to 1/2 times the total mass times the velocity of the center of mass squared, plus 1/2 times the moment of inertia through the center of mass times omega squared. And so this would be equal, mass total times g times h would be equaling 1/2 times the mass total times the velocity of the center of mass squared. This would be plus 1/2 times the moment of inertia through the center of mass times the velocity through the center of mass divided by r quantity squared. And so this would be equal to the total mass divided by 2 plus the moment of inertia through the center of mass divided by 2 times r squared, quantity multiplied by the velocity of the center of the mass squared. So the velocity of the center of mass will be equaling the square root of the total mass multiplied by g times h, and this would be divided by 1/2 times the total mass plus the moment of inertia through the center of mass over the radius of the inner hub squared, and we can solve. So this would be, for the numerator, 0.105 kilograms multiplied by 9.80 meters per second squared multiplied by 1.0 meters. And this would be divided by 1/2 times the total mass of 0.105 kilograms plus 7.038 times 10 to the -5th kilograms meters squared. And then this would be divided by 5 7.0 times 10 to the negative third meters quantity squared. Clean this up. And we finally obtain that the velocity of the center of mass would be equaling 0.8395 meters per second, or we can say approximately 0.84 meters per second. This would be our final answer for part A. And then for part B, they want us to find the ratio of the rotational kinetic energy divided by the total kinetic energy. And so this would be equaling the rotational energy. And we know that the total kinetic energy is equaling the initial potential energy. So this would be equaling 1/2 times the moment of inertia through the center of mass times v, the velocity of the center of mass divided by the radius of the inner hub, quantity squared, divided by the total mass times g times h. And we can say that this is going to be equaling the moment of inertia through the center of mass multiplied by the velocity through the center of mass squared, or the velocity of the center of mass squared times divided by 2r squared times the total mass times g times h, and we can solve. So this would be equaling 7.038 times 10 to the negative fifth kilograms meters squared multiplied by 0.8395 meters per second quantity squared divided by 2 times 5.0 times 10 to the negative third meters quantity squared multiplied by 0.105 kilograms multiplied by 9.8 meters per second squared multiplied by 1.0 meters. And we find that this is equaling 0.96. So the rotational kinetic energy divided by the total kinetic energy will equal essentially 96%. Most of the energy is in the form of rotational kinetic energy. That is the end of the solution. Thank you.